Alright, hi, we are Group 9. I am Lexi.
I'm Bo.
I'm Jimmy.
I'm Chaos.
And this is Apollo, the Dancing Alien. So the story and concept for our design is that 150 years after the first moon landing, a new exploration is sent out and astronauts discover a new alien, an excited little guy who just loves to dance. And so our target audience with this toy is definitely young kids. It was really important to us to create a toy that a child could really interact with and really play with. A big thing with psychology of play is to have free play where it's unstructured and a kid can kind of make their own story, do their own actions, and so that's kind of what we tried doing here. Like, there are the predefined dance moves, but as far as the story of what Apollo is beyond that, that's really up to the kid to decide, and they get to just interact with it and play with it as they see fit. So some of the key features is that we have some arm motion. Here,
Yeah, I can
face.
hold it.
So we have arm motion and then upper body rotation. And it also has the ability to speak and play pre-recorded music. So I'll exhibit that now. It only goes on for a little longer.
Don't worry.
So that's a little demonstration.
So when designing Apollo, it was really important to us that he could move as freely as possible in order to provide the most fun dance moves that we could imagine. And to do that, he has to be Purdue themed. Obviously, he has a huge influence on Purdue's culture coming from Neil Armstrong. Excuse me. And we thought it would be amazing if his arms could rotate around to boiler up and hammer down and simultaneously make his head bob up and down. And to do that, we rigidly connected a DC motor to his head, and using a series of linkages, we turned that rotational motion into a linear motion of a central rack that allows his head to go up and down. And at the same time, this up and down motion allows his arms to rotate, and this provides the bowling up and hammering down that he needs as a Purdue honorary alumnus.
So we, in our initial design iteration, we planned on using DC motor. So we purchased a 3-volt, 15 RPM DC motor for that function. But we'll be getting into detail why we have to move away from that idea.
So our other mechanism is a cam follower to provide not just a simple rotation, but a little bit of a bump, as you can kind of see in the animation here. So instead of just going back and forth like this, he's kind of leaning back and sort of oscillating a bit. So underneath this kind of neck piece, you can see the zoom in here. There's a oscillations of around that like circular place, and then it just follows through the central shaft. It follows that path as it spins around. So this allows for more oscillations as it's moving. Do you want to talk about the servo motor?
Yeah, and the servo motor was the standard servo motor that we had used in the guided design project. That was something that we intended to add to this design.
And so this was the total ideal motion that we wanted Apollo to have. As you can see, his arms go up and down, and his head moves both back and forth and up and down.
So during the prototyping phase, one of our main considerations was also for the body. So we wanted to be a slug shape so that it could house all of our components, as well as for the head itself. That's why we made it kind of bigger. And by having it round, it also adds a nice aesthetic to please kids. And all of our parts, we were either 3D printing them, or we were buying it through electronics, or getting some of the spare parts from the electronics shop in the W building. And by doing all this, this makes it actually a lot easier to assemble later on for the final design.
And one more thing that makes it much easier to assemble is, I don't know if you can notice from this picture, but there are no fasteners anywhere in the head. Every single piece is either press fit or snap fit together, and the simplification of design makes it much easier to assemble. It requires less parts in the BOM, and is overall much better from a manufacturing perspective. And So during our first iteration of prototyping, which you can see here, we encountered a number of problems related to incorporating the motors and electronic components of the design. So in general, we thought that the servo would work very well at moving him around, but in practice what happened is that the provided servo mount that came with the servo was very wiggly, and unfortunately it couldn't really stand up to the tilts that he has to go through, and it couldn't stay attached, and this just results in his head like kind of keeling over to the side, which is not very fun. And another issue we had is related to the arm motion controlled by motors, and unfortunately what happened there is that the motor placement ended up being in a relatively high torque area, which we couldn't really tell just from doing the CAD, because obviously CAD doesn't give you a feel for how things move. So we had to kind of make an initial guess, and unfortunately our initial guess was not quite right. So the motor would occasionally work, but occasionally it would jam up and the arms would stop moving.
So what we decided to do to improve this is switch it to manual control, because we realized that it still functions the same if you just move his arms by your hand, versus also you can move him along the cam follower as well. And it still has that playability that we were looking at.
So moving forward for our second iteration, we would love to incorporate our electronic components again and make it a more automated toy, so that kids can, rather than having to make him dance, can just dance alongside him and have a great time.
Yeah, like Bo had mentioned, we plan to, with more time and resources, we plan to use the Blink smartphone control app to add more speed variations to the model. So speed setting from 3 to 5, so that the cam follower can move along the shaft at various rates, and add more songs so that the kids can have a better experience and to attract a wider range of audience.
And so with that, we are done with our initial presentation. Does anyone have any questions for us?
What was the reason for the skirt kind of effect?
So this you talking about, this little piece?
No, just the yeah.
This.
This. So the initial design was that he was supposed to be a slug-based alien.
Okay.
Yeah, both in order to simplify the amount of features that he had to have in order to simplify manufacturing and all of this, and also to more effectively house all the electronic components that we wanted to incorporate. So that kind of necessitated a more amorphous form factor.
Go to the one that shows all the inside stuff.
Yeah. This one?
Yeah, that one's
Yeah,
fine.
just one
The
on the bottom
left you can see really well. So like we have room for up to 2 batteries. Our breadboard could be back there, and then when we were still integrating the electronics, all the wires were able to kind of sit back in this sort of dead space where it's not in the way of the servo, but it's able, and it's not tall enough to house anything else right here, so the wires were able to just kind of like hang out back there.
I'm really impressed with how it all fits together, like really, really well. How did you guys split up the design work to make sure that it all came together like really, really well? Did you have like one person who mostly designed it, or?
We split between the mechanisms mostly. So Bo was responsible for the arm linkages. I worked on the cam follower, and then Vyas worked with the head, and Jimmy worked with the design of the body.
Yeah, and for how it all well fit together so well specifically, we kind of worked within our own strengths. So personally, I have a lot of experience designing snap fit parts for injection molding, so I just kind of tend towards that naturally. And thankfully, it worked for once.
There you go.
Thank you. His head will be green for the toy fair. We just did not have time to spray paint it. He won't be a demon baby.
Thank you.